Well, yes, it's a pleasure, inviting Dr. Arindam Bose to this lecture series. I'll just give a brief introduction because he has to leave early. Dr. Arindam is a faculty at the Center for Excellence in Teacher Education, TIS Mumbai, and also a collaborative professor at the Federal University for Sao Paulo, Brazil. Uh, Dr. Bose was the Vice President, International Committee of the International Group of Psychology of Mathematics Education from 2021 to 2023. And this is also, I believe, the first representation from India in this position. He's also a member of the International Committee, Mathematics Education and Society, MES. Um, Dr. Arindam did his PhD from TIFR and interestingly works in the areas that I generally work. And I see his specialization in culture and mathematics, child development, cognition and learning, history of education. And I was just discussing that, he works on archaeology as a method for teaching mathematics. And I remember working on defreezing in 2008-9 when I was attached to University of Manchester as a method to unpack more tacit knowledge in everyday practices, especially the artifacts that we find in the everyday world of people. So I was really excited reading some of the work of Dr. Bose. So I'm going to be probably fascinated most by your talk. So over to you, Dr. Bose.
Thank you very much. Thank you very much, Dr. Panda, and also Varsha for inviting me to this lecture series. And as we discussed, this will be the first of my couple of talks. I'm also looking forward to my subsequent lectures, maybe next month and also later. And it's so interesting to to have known your work, Dr. Panda, and now having met you in person and seeing so many overlaps. And as you said, archaeology as a methodology is really, really crucial, and also from the Indian context where these things it has come up in your work, of course, but more such research inputs are required. So that is what I plan to actually talk about in this in today's talk. I would actually like to talk to the students more and see if it can create some interest among our students, masters as well as doctoral students in university. So what I want to say is every with language diversity and mathematics. Yes, Varsha?
Sorry, nothing. I'm still trying to figure out how to share because I'm not able to see the document, but I'll figure out. Sorry. Please continue.
Yeah, I saw the screen, but then it went. The slides didn't show. Arindam, it was breaking. Just speak again. Last two sentences.
Okay. So I'm saying that this talk I intend to talk to most of the students, in fact, master's students and doctoral students, and talk about how everyday cognition connects with language diversity and has implications for mathematics learning. So that's basically what the talk is going to be. I will first of all introduce what we collectively understand as everyday cognition, and then describe as a framework how we can use the knowledge of everyday mathematics vis-a-vis school mathematics as a framework to understand and reflect on how mathematics may be embedded in cultural practices, work contexts, and so on, which may be easily unpacked using this framework called archaeology. So that's where I aim to take this discussion towards. While doing so, I'll be using funds of knowledge as a framework, as a lens, and also various language varieties which one may notice in different cultural contexts using funds of knowledge as a lens. So this is what I intend to do. Uh, can you share the second slide? Is it possible?
Varsha? Okay, let me try. I'm not very good at, but since Varsha is not able to, let me try. Arindam, I'm trying.
No. Now I'm feeling bad for the participants. Yes, sorry, dear
You
participants, but
can continue talking because I'm also not too
yeah,
good at it. Let me just see.
all right. Well, I wanted to give this example of a fifth grader who once approached me, and I was in the class doing some classroom observation. And this is a school run by the municipality of Bombay, Greater Mumbai. And this grade was grade 5, Urdu medium school, located in a huge low income settlement. And this young boy, let's call him Abdul, a pseudonym, he came to me, approached me, and said, "Sir, आप मुझे तकसीम सिखाएंगे? Can you teach me division?" And when I asked him if he had done that in the class, then I realized that the teacher had covered the topic already, the long division method, and he was still getting stuck at some point, but he wanted to fix it. Now, the interesting thing here is this fifth grader who knew that he was faltering, but he was scared to approach his teacher. And instead, he thought, okay, this person could be more approachable or whatever, maybe friendly. That was also almost 15 years ago, much younger I was. And he must have seen a friend in me and he approached me, Sir, आप मुझे तकसीम सिखाएंगे? Can you teach me division? And this is where I get stuck. When I use the teacher taught method, teacher ने जैसा बताया बरोबर वैसा ही किया, लेकिन जवाब नहीं आता, is what he said. So I exactly followed what the teacher had said, but I never arrived at the answer. Now, whenever I tried to do some diagnostic testing, started with small numbers like 2 digit divided by a single digit and so on. I had a sense that Abdul was calculating it mentally and directly writing the answer. So for example, 36 divided by 3, he did not do 3 ones are 3 and then 3 twos are 6. Right, he directly wrote 12 as the answer. Now to catch him there, I gave him this number 981 divided by 9. It was there in the slide, you could have seen, but that's okay. You can imagine, 981 divided by 9. And what he said was the following, that 9 ones are 9, no ekam no, and then he put a 0 below, and then he took 8 down, and he felt that 8 was not divisible by 9, therefore he also took the 1 down. So it became 81. And then he wrote 9 nines are 81 and 0 0, and he stopped. And he started chewing his pencil, which indicated that probably he had what we call in cognitive psychology cognitive dissonance, something that he was not able to match with what his prior schema was. And so he was chewing his pencil and he said, "Jawab nahi aata." I tried to probe him a little more and I said, "Well, jawab to aaya na, ye kya hai?" "Haan sir, lekin jawab nahi aaya." But I wanted to tell him that, look, this 19 isn't 19 your answer. But he would not agree. But never did for once he mention that, did he say that it was incorrect. Because according to Abdul, this was what his teacher had taught him, and therefore, following his teacher's method, he was getting 19, and it couldn't have been incorrect. So he didn't say that it was incorrect, but he said, Jawab nahi aata. I don't get the answer. I don't get the answer. After lots of pestering, and you know, those who get into this kind of clinical method of interviewing, you know that, you know, even this kind of conversation for 2 minutes is a long conversation. So I must have continued for 2 minutes. And finally, Abdul became really frustrated, thought I was not getting it. While from my side, it was deliberate. He said, oh, sir, मान लो 981 रुपए हैं और 9 बच्चे हैं, कम से कम 100 तो मिलेगा ना सर. So he said, assume that there was 981 rupees as amount and to be distributed among 9 children, then each one would get at least 100, isn't it? So which actually meant that Abdul had this, this knowledge, this prior understanding, which I'm going to talk about later on as, you know, access to funds of knowledge, which gave him this power, where he knew that the range was near about 100. It could not have been 19, so less. You know, that was just not possible. So for him, it was an absurd answer. 19 was absurd. But, you know, in our cultural practices, we never, ever think that a teacher could be wrong. And we always have a faith on teacher's taught method. And therefore, for Abdul, you can see on the screen this 19. For Abdul, it was correct. It had to be correct because he was arriving at it using his teacher's taught method. But from his everyday experience, and he was working in a tailoring workshop in that low-income settlement where the school was located, and from his own everyday experience, he knew that it cannot be that less. You know, it cannot be, you know, the range has to be near about 100. And then he calculated mentally and he arrived at 109 by saying that 100 de do, फिर 10 de do and एक ले लो. So give away 100 and then give away 10 and take one back. So that's how he arrived at 109, which is supposedly mathematically correct. But it also depends, you know, what is mathematically correct is little, you know, something to think about in every context. So can mathematics be really singular? Can mathematics have multiple forms? Can multiple answers be correct? All that we can come later. We can discuss that later on. But anyway, Abdul then overwrote 9 with a 0 and then put this 9, which you are able to see on the screen. So it became 109. Then I asked him, so Abdul said 19 was incorrect. All he was saying was answer nahi aata, jawab nahi aata. So I said, kya lagta hai, kya dono jawab sahi hai? Then he was in a fix for a while, and eventually, what he said was really alarming for us. You know, he said, showing this 109, and because it was a classroom, he said, "ये 109 यहाँ सही है, and 19 बाहर सही है." Sorry, I'm saying the opposite. ये 19 को दिखा के ये 19 यहाँ सही है, 109 बाहर सही है. So one is correct here inside the school, and the other one is correct outside. Ostensibly indicating that, you know, it's okay to have one answer in school which actually, you know, fits or, you know, can connect with the formulae and so on, and it's completely okay to have something else outside. Now, this is the kind of disconnect that you often get to see among children, which often, you know, reports like Asar and others also indicate, but they many times they fall short of actually saying what is the reason behind it. Non-numeracy, you know, as lacking numeracy. But you will see in the next slide how children like him can actually be very conversant with handling currency, but may not be able to translate that knowledge to formal representation of this, numeracy, you know, the numbers. So here in this slide, you will see that there were 6th graders who represented these 5 and 13,206, which they had to take out from boxes of currency. And you see that on the left side in the figure, that child actually took two 1,000 rupee notes. Those days, 1,000 rupee notes were available. It was before demonetized. It was like 18 years ago, 17 years ago. So she took two 1,000 rupee notes, actually adds up to 2,725. But look how the child has added it. Now, going by this standard lakh numeracy, but from the number construction and numeracy, but is able to connect the amount, the currency amount with numbers. Same story is on the right hand side as well. There are many such multiple examples where one sees that children who have exposure to such out of school context or community funds of knowledge have different ways of understanding numeracy, number construction. They may be faltering in the decimal, so-called standardized ways of representation, but otherwise the understanding is quite concrete. And the disconnect comes because these two areas often remain disconnected. Let's move to the next slide. So I have these three questions for ourselves as to what attributes to children's math learning then. So there are insights which are required. So what kind of insights do we require our children to have in order to understand the basic mathematical concepts, foundational understanding, and then what sources of these insights may be which can relate with school mathematics learning, and finally, what understanding students must have in order to build newer, like building on concepts, mathematical ideas based on the basic concepts. So move to the next. Next slide. Am I audible? Is my voice going through?
Yes, sir, you are audible.
Yes, sir.
Yes, sometimes one or two sentences it becomes difficult, otherwise you are. This is the slide you want to be on?
Yes. Now, I wanted to argue here that there is a reason why we must also understand why it is important to look at mathematics present in the everyday cognition, present in the everyday setting. Most of the time it's embedded in different practices, which also emerged in post-Piagetian perspective, which actually calls that child's mind is not a tabula rasa, it's not a blank slate, but children draw a lot from their environment around, and they have a prior knowledge which is connected with what children are exposed to in their community, particularly community's knowledge resource or cultural insight, which we refer to as funds of knowledge. Now, most children, particularly those who are coming from the margins and those who are living in such huge settlements, having exposure to work context and cultural practices, often have access to such funds of knowledge. And it's an important source of mathematical knowledge embedded in practices which often come to the classroom. And there is enough reason now for us to take a look at and draw on that knowledge domain. Next slide.
All right.
So this is the slide talks about everyday mathematics. What I mean by it is basically out of school mathematics embedded in cultural practices, in work context. It's also referred to as street mathematics, informal mathematics. But whatever name you call it as, but it depends on it draws from the same mathematical principles, but probably coming from different, with a different form. Now, in the next three slides, I have given a framework which describes or gives you a distinction between everyday math and school math. So next slide. Next, there is a table. So that table, yes, this table gives you a framework which I call as distinction framework, which is quite useful for us to analyze what we can bracket as everyday mathematics or out of school mathematics and what as school mathematics and the distinction between them. In terms of these 6 parameters, the first one is basic feature, where while everyday mathematics is based on shared cognition, everyday cognition, which is largely socially shared, and where there is presence of group work, there's division of labor. Now, this is taken from Lauren Resnick's work, 1987. So basically, this is a review of literature and put it into a framework. On the other hand, school mathematics is based on individual cognition and mostly independent work where manipulations are carried out keeping symbols in mind and use of pure mentation is encouraged. On the other hand, everyday mathematics, drawing from difference in numeration, sees that it's oral in nature and where multiple units and operations may take place, but these are all situation specific, units. Whereas school mathematics is largely written, but use of symbols are quite standardized and the same for everyone. Let's move to the next. Here we see difference in procedure, and based on that, everyday mathematics uses contextualized reasoning, lot of instances where decomposition is used as a method and repeated grouping, and also use of convenient numbers. But in school mathematics, there is emphasis on formal reasoning, formal algorithms as part of the textbook, and which is also taught in the school, in the classroom. There are mechanisms, differences in mechanisms of acquiring knowledge. Everyday mathematics depends a lot on socially shared communication, socially shared cognition, legitimate peripheral participation. These are taken from Levin Wenger's work, Communities of Practice and Legitimate Peripheral Participation. That school mathematics largely depends on knowledge acquisition and knowledge building, which are largely textbook based. So therefore, the mechanism to acquire knowledge is generally language which are there, not just language and physical. It could be also different kind of non-verbal cues as well. But in school, these are largely based on individual thinking, where group work is often not encouraged. Next. Coming to the metacognitive awareness, everyday mathematics indicates that there is a use of confidence in procedure. For example, one would know exactly where one is in the midst of calculation. And you saw that in Abdul's case as well. Abdul had confidence in the procedure, what he thought as being as faltering, as incorrect, as absurd, something that people who are calculating orally or mentally would be able to prescribe or detect midway. And often results are obtained by carefully using these procedures, which are generally mental. And what I'm trying to indicate here is there is continuous monitoring, and they actually know where they are in the middle of the calculation. Whereas in school context, there is heavy use of algorithms, which often leads to lack of meaning making. Children may be able to do the algorithms, but they may not know why something is working. So there is lack of meaningfulness and relevance, and continuous monitoring may not always be possible. It's only when you finish the calculation, like division algorithm, you complete it, and then you know whether it was correct or not, as was in Abdul's case. And test of acquired knowledge, in the everyday context, there is no formal examination, while school mathematics is largely, formal exam driven. All right. So drawing this framework, let's move to the next slide. Now, drawing this framework, it will be helpful, easier for us to understand what forms mathematics is embedded in practices, and which we can try to uncover. Go to the next, please. Now, coming to the next part of the talk, which is language diversity, we notice that even within work context and practices, there's use of language repertoires, which is part of that practice, part of that work practice, which I call as language of practice. The previous slide, please, which I call as language of practice. Now, many of these language practices are part of the community's funds of knowledge, and which children living in that area have access. Previous slide, please.
Is this the one, the case of fraction?
No, the previous one, language repertoire, language diversity.
This one? Case of fractions.
Go to slide number 12.
Slide number 12. That's language diversity.
Yes. Yes. So one can see that in the everyday context, there is quite wide range use of code switching. So in one language, using more than one language, words or phrases from more than one language, or just translanguaging, moving from one language to another, which is an emerging feature now with more and more migration and more movement of population. And in multilingual context that are, we see more multilingual work contexts, which attribute to development of such practices, language practices. Now, such code switching and translanguaging also add to the language repertoire by building on the language repertoire, not the technical work. There are diverse language representations and language use, which is part of the community-based resource. Let's move to the next. I would like to use the knowledge of fractions among children as a construct of language diversity and indicate to you how I'm trying to connect these three. Now, in the local context here as language of practice, you see that fractions are commonly used to represent quantities which are part of a whole. But commonly used everyday context, everyday registers also use registers such as half is a word for half called adha, also pav, which is a quarter, ardha pav or adha pav, half quarter, then pauna or teen pav, which is three quarter, and so on. So much so that often, to represent 0.75 or how much would 0.25 plus 0.25 plus 0.25 would mean, children have responded as teen pav or 75, like 75 or three quarters, even though they could not arrive at 0.75. So these language of practice or these commonly used language repertoires are really quite common, and these representations are also quite common to children, and they understand these representations well, even if they are not able to connect it with the decimal representation often taught in school. And everyday registers where mathematical connotations and representations are embedded. Next slide. So in the fraction subconstruct, which I'm using in the next slide, you will see that fractions appear in the school textbook in 5 subconstruct form, not just only as part of the whole, but also as a ratio, as an operator, as quotient, as measure. But often in the everyday context, it's only the part of the whole, and sometimes the ratio construct, which also emerges. And there is a gap or less of connection between these subconstructs, which researchers have indicated to as having or bearing misunderstandings, the lack of comprehension, or fraction being seen as a hard spot. Okay, next slide. I want you all to think about this task. If 12 laddus come for 42 rupees, so 12 laddus cost 42 rupees, how much would 15 laddus cost? When you are solving it, please also be mindful of the procedure that you are employing.
Next slide. Arindam, do you want me to move to next slide?
So I'm not asking you this. Can you hear me? Yes.
Yeah, we lost you for a minute. Yeah. Say it again then.
Yes. Can you move? Yeah, move to the next slide.
Okay.
It is very interesting to see that in many cases, one tries to find the price of one laddu and then raise it to 15. Using the popularly known as unitary method or Aikik niyam. So finding price for one unit or one ikai and then going to raise it to the number. Now, often do we not realize that one ikai need not always be one, depend on the context. And many students, and it's very interesting to note that those students who were labeled as underperformers in school were actually the ones who noticed that it is the price of only 3 laddus which was to be found, and not 12, or not 15. Because price of 12 was already given. It's that difference which if you find, you're through. And they also noticed that 3 has a nice relationship with 12, which is a pav, a quarter. Now, it all needed to just halve and half twice. So divide 42 by 2, take half of 42, and again another half of that, which added to 42 will give you the result. Now, this form of calculation, which is embedded in everyday practice, everyday cognition, is part of everyday cognition. It resonates well with our argument that this indicates the multiplicative connection that these two quantities have, namely 12 and 52, 12 and 15 with 42 and the answer, which is 52.5. In fact, many students actually said that the answer would be 53 because the shopkeepers never returned the balance. Dukandar athana nahi chhodta, therefore it would be 53 and not 52.5. The point here is, as part of everyday cognition, one also notices such proportional reasoning, multiplicative reasoning, or relation between quantities, although not structurally formed in a formal sense of things that we do in the textbook. Next slide, please. Coming back to funds of knowledge, so we notice that many such embedded practices are part of everyday cognition which children are exposed to. And these are part of the community-based rich cultural insights and knowledge resource. And as a framework, when one can use this lens to uncover many such mathematically embedded practices, where the form of embedded mathematical practices can come from different ways of approaching the same task, not just from the school method, but also different other ways, which can actually give further insight and different ways of, meaning making or adding to the foundational understanding of the relations, quantities, and relations between them. So the final slide is about what we call as archaeology. In fact, Dr. Panda also has worked on it as a pedagogical tool in 2008, 9, that period. I'm redrawing that idea here as a pedagogical mode to argue that this pedagogical mode helps us to inquire into what we call as sedimented mathematics or frozen mathematics, or frozen construction of ideas which often remain opaque. And it is important that we unpack. For example, in this community practice, one also notices a lot of measurement knowledge, which I will be talking about in my next lecture, which remain opaque. But the constructions are quite interesting when we try to unpack and see. And they are related to the way we teach mathematics in school, but only using a single standardized technique. But there are multiple such techniques which are embedded in our practice. Now, the opacity of these underlying constructions can also be understood through what we call as the perspective of demathematization. Because the world is becoming more and more mathematized in a sense that we do not really need to know or understand mathematics anymore. The machines do it for us. Calculators do it for us. These log tables do it for us. Many of us are paying EMIs. Hardly do we even care or bother to check how these EMIs are calculated. And we don't even bother. So we are getting highly mathematized on one sense and therefore becoming demathematized. There is really less requirement of understanding or knowing a lot of mathematics because machines are doing it. Now, we argue, so me and my PhD supervisor, Ravi, we argued that, and we keep on think about it, is to see how this onslaught of demathematization is getting arrested, stopped by these, funds of knowledge which are embedded in such cultural practices, which do not let them getting mathematized more and hence getting demathematized. So in a way, we say that this kind of archaeology can also help us to arrest this onslaught of demathematization. And therefore, they can involve many mathematical principles in the broader sociocultural term, which can help us understand and see how this demathematization process can also be arrested. So I will stop here with a few references in the next slide for you to check. And I would be interested to have some Q&A with you. Next slide.
We don't have time. So I think let's take, I thought of discussing some, but we'll do it next time. Let's rather take questions from the audience. I'll stop sharing, isn't it? How to stop sharing? Okay. Yeah. All of you can now ask questions. You can raise your hand or unmute yourself. You can also switch on your video and ask directly. Otherwise, you can write your question also in the chat box. Arindam can look at it. Varsha, can you also check the chat box if there is any question?
Yes, I can.
Yeah, Arindam, I just have one query. So the archaeology when you were talking about, so the knowledge is, like people do use, the knowledge is frozen in the activity. I mean, we can't see, but we perform it well, and there is mathematics embedded in it. And so when you unpack it, like you engage in some kind of discourse and make, the user of that particular, knowledge through a tool or anything, talk about what kind of mathematics are involved in that. You call that demathematization, or you call, I think towards the end, what I thought that you were saying, because mathematics is invisible, because it's a kind of practice we engage in and we perfect it and we perform it. And so we really don't think about the kind of mathematics, that are gone into it. So we, we perform it, but at the same time, we don't mathematize that context. So you call that demathematized or unpacking demathematized? Which one you're calling demathematized?
No, demathematization is coming because there is lack of need to know a lot of mathematics. So we can get away with our lives and practices without knowing mathematics. So the world is becoming more and more demathematized.
Yeah, who used it? First time who
Sorry,
used it?
am I audible?
Yeah.
Okay.
Can you
I'm
hear?
saying the world is
I
becoming
heard
more
it.
and
I
more
heard it.
demathematized.
Yeah, I heard it. So,
Mhm.
but why do you call it demathematized?
Because there is lack of need of mathematization anymore.
There is
You see,
no.
so we may be using these ideas without knowing how mathematics behind it is working.
Okay,
We
got it.
completely rely on these tools,
So not
whereas
tracking, but this one, yeah.
yeah,
And
whereas
who used it
the
for the
irony
first
is,
time, Arindam? Who used it for the first time?
well, it's there's a book by Uwe Gillert and Jablonka called
Hmm.
Mathematization and Demathematization,
Oh, yeah,
2010.
Varsha was showing me, right? Yeah.
Yeah. I think
Yeah, that's
2010.
interesting. Yeah. No, I never used this term. I rather used defreezing as I was saying. That's like making the invisible visible kind. At
Yeah,
least talk about.
I find it a very useful and powerful term because
Yeah.
more and more that we are getting used to this technology and so on, the world is advancing,
Technology is
and if
high.
we see, yeah, things are getting hidden, and we really don't need it. Whereas those who are not being so much technologically advanced and still depends on communities' funds of knowledge are the ones who continue to be able to use embedded mathematics,
Yeah. So
not demathematize.
thank you, Arindam. Please raise your hands if you have any question or query, or you want to compliment the lecture. Okay, let me see where is. You don't have any questions? Varsa, do you have any question?
No, ma'am. Away right now. I don't have.
Okay. Yeah, since nobody's asking any question, we can engage in some dialogue, isn't it? Um,
Yeah.
okay. I'm doing a paper on ZPD, zone of proximal development. I'm using a term trans-knowledging, and multilingualizing and trans-knowledging, and I'm applying that to mathematics. And in that, I was using some metacognitive methods, but then making those metacognitive inputs or thinking accessible to students for dialogue, between them. So even when they think it's still inside their mind, it's accessible to them. So we just make them verbalize it and then talk about them. And uh, I mean, how do you see that as a method? Because in you know, talking about a mathematical concept in specific ways with young children is also not very easy. They discover the whole discursive protocol gradually, you know. So when we work with them, I mean, we assume as a cognitive scientist, one will say that, okay, mathematics learning also is partly mediated through, or maybe greatly mediated through metacognitive exercises, but that's internal to the student. But when we use that as resource, and uh, how do we face this challenge of getting these students also to come into a discursive protocol of mathematics so that they see in mathematical terms, many times they don't see it in mathematical terms. Have you used it ever?
Yeah, it's a very good question.
My early writings was on how mathematics is.
In this example.
Yeah.
Uh,
Yes.
Minati
Oh,
ma'am, Karthik has posted a question. He wants to ask something in the chat.
Yes.
yeah.
Yeah. I've seen that question by Karthik. Let me first respond to Dr. Panda's question, and then I'll move to Karthik's question. Yes, Minatidi, I think it's a very good question and something which is not answerable in a very straightforward way.
No,
But
I
I think
know.
I continue to use Abdul's example as metacognitive awareness, where one requires this this small bit of zone of proximal development, that kind of scaffolding, and after which she was very clear. And it was also coming because, you see, we never start our multiplication tables with 0. We can actually say 9 zeros are 0, and then 9 ones are 9, which would have actually resolved his problem. He got stuck because he felt 8 was not divisible by 9 because it is not coming in that table. Because the table itself starts from 9. But if we had done it with 9 zeros and 0, this is a very small example of how one can give a scaffold and which can for all
expanding the
expanding the
imagination.
and then
one
place value.
Say.
Sorry.
Please.
Yeah, go ahead.
No, Arindam, you continue. I'll tell after you.
So, I mean, that can actually can take care of the place value errors as well. And can give a long-term solution. But the point is, many times, these are missed and not seen as a resource. But
And
yes,
also,
metacognitive awareness is quite prominent when we are doing calculation or actually trying to unpack how calculation or a particular insight was arrived at. Then we realize that at every step they knew where they were. So that's metacognition.
I'm doing that now. If I'll call you and discuss, because I'm writing this part now. I thought the first part I have done enough in the past, so let me look at this. This 0 times 9. What I also realized that in mathematics, when we work with younger children, many of them come from very pedagogically driven families, where mothers are working with them all the time, giving them solutions. And there are more questions. I'll be very brief, just half a minute. And so they first calculate and then later discover the real mathematical principles. So sometimes these templates, like 0 times 9 may stay as a template for in the beginning, but may become a source of mathematical insight at a later stage. So this is a good idea. Can you respond to Karthik's question? And there is
So Karthik, there is a lot many way in which mathematics can attribute to development of critical thinking. For example, you can think of, there's a good book by Eric Gutstein, Gutstein, called Reading and Writing the World Using Mathematics. So Pedagogy Towards Social Justice. All right, so there he tries to connect mathematics. Can you hear me?
Now. It just broke for 5 seconds.
So there he uses examples of F-16 aircrafts built by USA. And the context is of 2001 when World Trade Center was attacked. And US was increased its spending on defense budget. And Gutstein is arguing a cost of constructing one F-16 aircraft is equivalent to paying, say a n number of universities for 10 years for 3,000 students, for example, say for 10 years with full scholarship and so on. All right. So we understand these numbers may be really big, or when some schemes are launched here and we say 15 lakh crore and all that, we don't understand how big that number is. And even there's some number numbness. Yes.
And also in to other aspects of life, human life.
And there one can really see these comparisons, and these comparisons are actually coming from critical lens. Using critical theory, one can actually use mathematics as a premise to drive critical thinking skills. So Karthik, in fact, I see mathematics all the more important and as an important premise to engage in questions of critical thinking.
Yes, I think there is another question. Can you check your text?
Yes.
I am Mohammad Farid, ma'am. I have raised my hand. Can I ask the question?
Sure, Mohammed, please.
Yeah, good evening, sir. So during your presentation, you have used about the word uh, algorithm use actually. So if we're using an algorithm a lot in the school at the level that, so is that taking the child in a cognitive level in a good direction or somewhere else? Just I heard during this
I
one.
think
Yeah.
I think I was trying to argue that school methods are heavily dependent on school procedures, which are algorithmic procedure. For example, this Abdul exam, I mean, this long division method, the way we divide or we teach children to do long division is basically following an algorithm. If you get this, do that. If and then, there's a chain of if and then. So that's one algorithm. So I think I was trying to say that most forms of school mathematics are heavily driven by such algorithms, like different steps. If this, then do that, that kind of thing. You see that in geometry, in
Hmm,
construction of proofs.
hmm.
You see that in algebra, in solving, say, a quadratic equation. You see that in geometry, in trigonometry, many places, So the school mathematics is a collection of algorithms, formal techniques, which one has to learn.
Sir, one more question I have that. Now we are in the age of AI tools and technology is very much fast now. If we are comparing the very older method where the child used to have a calculation on the mental level, so which technique you find more convenient?
No,
Means,
I don't think there is a competition between any of these. It's more of for our understanding that in order to enhance meaning making, and you are
okay,
right, we are driven by AI.
yeah,
Therefore, understanding of mathematics becomes all the more important.
hmm,
And you see, for building that foundational knowledge, what is required is to
hmm, hmm,
have better understanding of the procedures
hmm,
and not just use them as formulae.
hmm,
It's
hmm.
better to understand why a formula works,
Okay,
than to just use it, which we are
okay,
often doing. And that's what I'm saying as demathematization. We are
okay,
becoming more and more technologically
yeah,
advanced, but getting many very detached from mathematics, from the need
okay,
for knowing mathematics. That was the argument. There's no competition between the two.
okay. Thank you very much, sir.
The
All
mathematical.
right.
Uh,
So let me read
Good
from the
evening,
chat
ma'am.
box.
This is Geeta Rai. Can I ask a question?
Yeah.
Good evening, ma'am. And good evening, sir. I have a
Let me
question.
respond
Can I
to
ask,
the.
please?
May I
Huh.
respond to the chat box first because they asked long
Right,
ago?
right. Sure,
Yeah.
sure.
Then I'll get back to you. So Yatri is asking the current formal education system in public schools are restricting children to express their thought of mathematization. So they are unable to link local, his or her local language and knowledge into formal mathematics. That's correct. And that's one of the reasons why, the technical terminologies, the technical register often remain disconnected with the language of practice or the language which children may be aware of. And which is why often the meaning making takes time and remains disconnected. Devanshi is saying, as we can see, a child is able to engage with maths in daily life and surrounding more than in the classroom. Then how classroom should be designed so that our concepts reach out to students more easily and they don't see mathematics as a burden? A good question, a pedagogy question. This is precisely what we have been discussing, Devanshi, that the classroom should become a space for meaning making, and the context should be not very familiar, not foreign, but something which children are familiar with, both in terms of context as well as language. So the terminologies, the registers that we often use are quite technical and detached from the way they are used in the community, in community practices. Probably the child is aware of the context, probably the child is aware of the registers, but since we're using the technical registers only, it remains disconnected. So a classroom would be a nice space where children and teachers are able to explore together. Various forms of meaning making is allowed and not just one form. Very briefly, yeah. Yes, now I can take your question.
Geeta?
Good evening, sir. Basically, what I wanted to ask was, is it the knowledge of the target language that helps you to solve or understand mathematical questions, or is it the formulas which we derive, Because formulas basically you may memorize and then, you can solve the questions in mathematics. But when the child comes to, the problem solving, it is that time, maybe because the language the child may not understand, he or she may not be able to solve the problem. How much, it is important that critical thinking is important here, or practicing is important here? I would like to ask you this, sir.
Well, you answered your question yourself. You see, of course, meaning making is important. Foundational knowledge is important. Building the foundation is important. Now, how we do that is, there could be many ways of doing it. And in our exploration, what Dr. Panda is doing, or her team and my team here is doing, is to understand what is working, for those who are often out of the school system or have never been to. See, one of the irony is this, which is driving our work. Those who are part of the school system often find mathematics as scary, fearful, and often drop out. But it is those who are either have dropped out or have been thrown out of the system who are successfully continue to successfully use mathematics in their everyday context, isn't it? Now, why is that so? Why is it that those who have remained out of the system or have given up or dropped out are the ones who are successfully using it? It's also because one is there is nothing to lose, for that matter. There's no pressure of performance or failure. But on the other hand, there is this rich cultural insights or different ways of approaching a solution, which often remains disconnected in the school context. And it is precisely this pressure or emphasis on formulae and practice, drill and practice. Karat karat abhyas te jarmati hot sujan. So that drill and practice thing is often creating more fear. The fear of unseen questions, fear of what will happen if I do not do this, fear of failure is often causing more, disadvantage towards learning mathematics than if we are able to bring in contexts which are more familiar. If we are becoming more familiar with people, how people in different community spaces work or are managing, probably are going to give us more insights. It's all about trying to find better ways than giving a straightforward solution. I do not think there is any straightforward solution available, to this.
Thank you
There's
so much,
actually
sir.
a
Thank you.
little larger. There's a little, see the school mathematics, sometimes some people claim that, mathematics has a language of its own. Yeah, it uses specific registers, but the formal mathematics uses a lot of semiotics, symbols, and those symbols have specific meanings. And we also, to maintain precision, we use certain registers more frequently, and that economizes the way we read and write. And so, since canonization also, the writing is done using all these. So, school mathematics also requires introduction of these semiotic tools, to think about mathematical concepts in their everyday world, But in school mathematics, I think we need more than just language. That's called metonymy. Like we use many symbols. So it's a little more complex, isn't it, Arindam? It's of course, like
It's not that straightforward. You're right. I mean, this is very complex,
yeah.
and it's not straightforward.
David
But
talked about this. Yeah, it's a little more complex because it's data. it uses so many semiotic tools as metonymy, and unless those are introduced to children, they don't have the linguistic facility to think using formal academic language, and that works as a deterrent at some level for many children who drop out, even though they think mathematically. Any more question? I think Arindam is now getting ready
Has
to
to leave, yeah, for the meeting.
Yeah. Any more question? Last question we can take.
We have two questions in the chat box. If you can quickly read them and just respond them briefly, and ma'am can follow it up later. That we can do.
Yeah, I can take one or two questions after you leave. Just see if you can respond quickly to this question.
For Shubham's question on FLN, I think Shubham, I tried to address that in my earlier slides. You see those decimal forms, we're actually able to take out equivalent amount of currency amounts, notes and coins, which actually indicates that they may not be able to represent in decimal representations, those numbers, but they had a sense, they had numeracy. You see, so what do we mean by numeracy? It's not just about being able to write those numbers and do the operations. There's more to numeracy than what we see or define them as. You see? So it's not just the way FLN is being conceptualized has a very narrow idea of, only being able to write or represent the numbers, being able to operate and so on. But it's more broader. It's also about number constructions, understanding how a number is constructed, understanding relationship between numbers, and so on, which these children have, and that's evidence, even though they were not able to write the numbers as we wanted them to. See, so therefore, one has to look at FLN with a more broader sense of the term. And the second question is, we can discuss this, Shubham, later on. You can send an email to me. Lopamudra's question about relationship between language and mathematics. Of course, foundational stage, it's in fact, it's only language and mathematics which are foundational. And that's the reason why it's FLN, foundational literacy and numeracy, although it's taken in a very narrow sense. We would often like to have.
I'm really
but,
this term foundational, but it's okay.
Yeah. Well, yes. Yeah. So I'll have to take leave now. Yeah. Thank you very much for joining it, and we will continue it next time as well. Over to you.
Yeah, we'll get you back to this lecture series again, in January or so. And and we'll that time have at least 2 hours.
Yes, I'll have a longer one. Yes.
Thank you. Thank you for quickly agreeing and doing this talk, and we'll continue on many issues.
Sorry for this technology disaster, but
yeah, I said thank you for agreeing to deliver this lecture, and we'll also continue to do few things together because it's the same area. So thanks a lot.
I'll take you later. Thank you.
Okay. Thank you, ma'am.
Thank you, everyone.
I will respond to last two questions,
Okay, ma'am.
We can spend 10-15. Do you want to discuss for 10-15 more minutes?
Yes, ma'am. We should continue. Yeah.
Okay, maybe 10-15 minutes we can do. In a year, this Subham's question, when we talk about numeracy, we can see that a set of learning outcome is being prioritized. So, sir, will this help in building a stronger foundation or have the opposite effect? See, as much as foundational, this FLN, I understand. Now that a lot of routinization has happened, like it's a separate stage with specific learning outcomes. And it's, of course, a little more children-centric. They come early, but, they still get pedagogically mediated instructions way more. As a result, my fear is sometimes that the spontaneity with which we build mathematical knowledge and the kind of time mathematical knowledge requires to develop sometimes gets scuttled in a very, very program driven and very well-defined, segmented kind of curriculum. So I mean, we'll have to wait and watch how FLN is actually contributing to mathematics learning. Yes, it can, because there's a lot of pedagogic exercises, but if it is done in a very restrictive and learning outcome driven manner, it might hurt mathematics learning, because it's in the nature of mathematics learning that it requires way more time, autonomy, and also freedom to for the individual to think about mathematical concepts and ideas. So let's wait and watch how FLN is going. Second question, I mean, Arindam has answered. I just want to complicate it a little more. Language and mathematics are foundational, we say. I don't know what does this foundational mean. One thing is that suppose you are talking about literacy skill. Yes, I mean, these classes help. But language is already develops very early, in children. Mathematical ideas, dealing with quantities also develops early. But then what do we do with these two in this stage is, will tell us how successful we are in giving a very, very rich literacy experience to children. So yeah, they're related, but at the same time, mathematical imagination is free of language at the same time. I will not say that language mediates mathematical cognition in entirety, no, because mathematical reasoning also operates through images, through concepts definitely, and images, but not necessarily language. Only at a later stage, when we express everything through language, mathematics will also require language. But if I say that we imagine we can have a mathematical imagination only when we have a language, no, we don't require it. So I think this relationship also has to be understood both as a cognitive phenomenon and also as a social cultural context. So I don't think we have discussed this in any great length, the relationship between language and mathematics. And Ramakant used to tell me that language is also, mathematics is also one kind of language. And in my early career, I used to say yes, but then later on I realized no. I mean, just saying it, probably we actually lose sight of the real problem that mathematics has when we bring the semiotic medium to the dialogue. So mathematics is not language, definitely. Mathematics is mediated by language, but is not language. And therefore, it has to be complicated way differently than we presuppose when we say language is also mathematics is also a language. I think these are very technical questions we can take up sometime in future, but we need a lot of cognitive input here. I think education is, and sometimes mathematics scholar, because I know Anna Safford is very well trained in cognitive science, but sometimes, mathematics scholars are not necessarily trained in cognitive science. Arindam, I'm really pleased to see his training in cognitive science. As a result, they gloss over questions like this. And sometimes we communicate wrong things also, like mathematics is also a language, no? And similarly, by separating a stage and developing clear learning outcomes will give a push to numeracy. Could be, I'll not say it's a myth, but by separating or having more defined learning outcomes, I don't think we may achieve higher. But I'll have to wait and watch. Let's see after 5 years if our students are better prepared in numeracy practices. But if they get literacy inputs, that helps. So they should improve. But no, I mean, you need more work, you need to do more works. I think we'll stop here, Varsa. We'll take up these questions. What we're doing is we're also recording the kind of questions that are coming. and we will develop more technical sessions based on these questions, and especially where
Mhm.
there's too much of glossing over, too much of mythification, and too much
Mhm.
of simplification. Simplification is needed, but not at the cost of rigor. And this is an academic platform, we'll just discuss concepts, but in an accessible language to everybody. So we'll take this up in future.
Okay, ma'am.
I think
We'll
Varsa,
wind up for now. Thank you all of you for joining. And as you are all hearing continuously, that we will continue this discussion. And thank you, and hope you join next time. Thank you. Bye bye.
bye-bye. And I must thank Varsa for taking a lot of time and spending a lot of time and energy in organizing these lectures. So thank you, Varsa, and thank you everybody for joining this.
Thank you.
Thank
Thank you.
Thank you, ma'am.
Yeah, we'll
Thank
also
you.
have a Varsa. Let's also have a group.
Mm-hmm.
I think all of you can send your email ID. Shall we do one thing, Varsa? I think because we are
We will wait
recording.
for a while and just type your email addresses
Can
in
you
the
just
chat
type your
box.
email ID in the chat box? We'll also form a group. So whenever we do small writings, we can send. I mean, all
And
of
for the next meeting, we will directly add you to a Google group. We'll create a Google group and
yeah.
you'll get the invitation directly to your email address.
All
And
of you may kindly type your email ID.
and those who have and who are interested to join this discussion, you can convey the message to them as well, and you can share your their email address to us.
I see Loknath Pandaja here. I mean, he worked with me in. Hello, Loknath. You can unmute it. Unmute yourself. Yeah, I can see somebody, one person who worked with me in early phase of NMRC. No, I mean in Emily Plus program.
I think I can see Gunjan here. He was my leader in EPF, and today when I sent this notation to him,
Namaskar, madam.
Ah,
Namaste, madam.
Namaskar. It's really nice to see you. So we'll
Thanks you,
sit
madam.
down a little more regularly. So,
Ji, ma'am. Ji, ma'am. Sure.
so when he said that he is a classmate of Arindam, and
he?
he was a classmate of Arindam. They had the same teacher, I guess, Vikas.
Oh,
Yeah.
Achha. Ravi was his teacher as well.
Yeah.
Ravi was a great, good friend of mine.
Mm-hmm.
Earlier, we used to be in many committees together.
Today was it's like introduction. The talk was an introduction to the whole theme itself.
Yeah,
Felt
so yeah, what we'll do is that we'll take a small theme, isn't it?
Mm-hmm.
So that our engagement will be deeper. Like similar, suppose, demathematization, just
Yeah.
taking it for 10-15 minutes. We'll gradually come to that since we have started. Once we start, we do. So we'll gradually get into more deeper and complex issues and where we'll complicate everything, every possible argument. Yeah.
Okay, I think we can wind up now.
Yeah. So, okay, then I can leave now, Varsa.
Okay, yes, ma'am. Yeah. I will get the email addresses and form a group. Okay, you
Yeah.
can leave now. Thank you. Thank you very much for joining today.
Thanks, Varsa.
Hello, can I come in? I am Gurjeet Varsha.
Yes, ma'am. Boliye. Yes, boliye.
हाँ,
You can
so
introduce
I'm
yourself to us.
I
Yeah.
teach at Jamia.
Oh,
So
hi.
somebody just sent me this link. I just joined. I just peeped in. So I would want to be a part of this group. So is that allowed or is that not allowed?
Absolutely, ma'am. This is a public platform, public discussion. That's why we are doing it. And we love
Okay,
to have
okay.
you, like scholars like you, and connected with us. Yes,
Please
definitely.
connect. And if anytime you want to contribute, you want to speak,
Yeah.
Okay,
specific
sure.
question,
Thank you so much.
gradually I will expect speakers to take a small topic and then deal, in depth, go in depth at least. And so we invite also, speakers if you want to
Yeah.
participate.
Okay. Thank you. I cannot switch on my camera just in a meet somewhere, but I just would like to be a part. Professor Minati, we met together at Jamia a few years
Oh
back, I think.
yeah.
I coordinated a refreshers
Yes.
for
Yeah. Now I remember. Yeah.
So one of my students sent this link. It sounded interesting. So
No,
I
no,
just
good
thought
you
of doing it.
joined. So let's meet. Let's catch up also in future.
Sure.
Bye
Thank
then.
you. Thank
Bye.
you. Bye.
Bye everybody.